Okay, so what we're going to have a look at here is sliding filament theory. We're going to start out with the resting sarcomere, or the muscle at rest. You can see we've got the myosin head, we've got ADP and the phosphate ion attached to it, and in the middle here we've got actin, which is the red balls, and we've got troponin and tropomyosin. Now troponin and tropomyosin are actually wrapped around the actin, and at rest the troponin active sites can't connect to the myosin heads. So when there's no calcium in the cell, the orientation of these little active sites means that the myosin can't join up with them. And if we progress on, when calcium comes into the cell, what actually happens is that these sites are shifted slightly so that the myosin can actually connect to them, the myosin heads, and that's the action of calcium. So when that action potential comes down, crosses a neuromuscular junction, causes calcium to be released into the sarcoplasmic reticulum, then that calcium floods the muscle cell and the troponin becomes available to the myosin heads. What's happening now is that those myosin heads are connecting to those active sites, and the next stage is what they call the power stroke. Now, during the power stroke, the ADP and the phosphate ion that was sitting on the myosin head are ejected off and release energy at that time, and the energy is what is used to actually make that power stroke. Now obviously this looks tiny in terms of it's just one little unit doing this, but you imagine millions of these things happening at once, pulling the actin along, and so obviously that's how you create a contraction. So now what happens is ATP comes back in, binds up to the myosin head, and then it's hydrolyzed, which puts it back to an ADP and P state, and then we're back at the start here. Now as long as there's calcium around within that cell, those sites would be active, so this cycle would continue. So the two qualifiers are, for a contraction to happen, I must have calcium within that cell, and I must have ATP that's come back in and allowed this myosin head to release and to be hydrolyzed and ready to go again. So one of the things that obviously happens is rigor mortis, which is when someone passes away and soon afterwards their muscles get quite stiff, and the reason for that is that there's no supply of ATP, so the muscle is bound up, and because there's no ATP to come in, it can't unbind. So of course it looks like the person's got contracted muscles, and they're actually just locked. And the reason they're locked is because these myosin heads are bound to the actins, and there's no ATP to actually release that again. So yeah, if you're ever wondering why bodies look terribly unpleasant for the first 2 to 10 hours after they've passed away, well, that'll be why.